Hello everyone, and welcome to Pre-Calculus Chapter 3, Lesson 1, Quadratic Functions and Models. In this lesson, we're going to review some of the ideas that we learned about quadratic functions, and then we're going to apply them to certain situations. So let's start with that review. A quadratic function is a polynomial function of degree 2, and the format that we learned last year was a format that we called standard form. But this year, the book uses that to mean something else. So the form that we learned was ax squared plus bx plus c. This year it has no name, but last year we called it standard form. And there were a few things that we could figure out just from this format. We looked at the a value, we looked at the max min point, and we looked at the c value. So let's see what all of those mean. If the a value is positive, it will be an upward parabola. If the a value is negative, it will be a downward parabola. So just from looking at this format, you can tell if it's upward or downward. You also know if there's going to be a maximum point or a minimum point. You can find the axis of symmetry using the formula negative b over 2a. That is an x value, and it will provide a vertical line at that point. To find the vertex, you take that axis of symmetry value and plug it in to the function. And the x value will be the axis of symmetry because that's always where you're going to find the vertex. And then the y value will always be the value after you plug that in. And then finally, the y-intercept would be the c value. That's this last number here that doesn't have an x attached. If there is no last number, then the y-intercept is 0. Okay, so let's look at the other format that we have for quadratics. This other format was called vertex form last year. This year they're calling it standard form. So if you see in the directions, please provide standard form. They do mean this format. It's f of x equals a times x minus h squared plus k. Now, h and k are just variables that mean that they're the x value and y value of the vertex. And they would be numbers in a normal standard form equation. There doesn't have to be an a value here. If a is 1, there would not be. And please note that these do represent horizontal translations and vertical translations. So when you pull them out of here, you would change the value on your x. The sign would be positive instead of negative, or negative instead of positive. Now, the vertex, which we find from vertex form or from using that formula from the previous slide, will either be the maximum or minimum of the quadratic, okay, because it is the lowest point or the highest point, depending upon if it's going upward or downward. So let's take a look at an example where we have to change an equation from that nameless form that used to be standard form into what they are now calling standard form, which is also known as vertex form in some cases. Okay, this is something you should have learned in Algebra 2 called completing the square. That's how we would do this. And what we're going to do is we are going to follow the steps of completing the square. Remember, this is a function, so you are not allowed to cross this equal sign. And we're going to start off by grouping our x terms. Grouping the x terms just means that you take parentheses and put them around the two terms that have x's. Next, you're going to factor out any number that's in front of your x squared. So even if it doesn't go evenly into this 12, you still need to factor it out, and you would end up with a fraction here. So I'm just going to divide both of these by 2. The 2 would go to the outside here, and we just have x squared minus 6x on the inside. Okay, next what we're going to do, we're going to take this number that's attached to x, also known as b, we're going to divide it by 2, and we're going to add b over 2 squared on the inside, and then we're going to subtract it on the outside. But just be careful, because we factored out this 2, we have to multiply by that 2 when we take it out to the outside. So on the inside, we'd add 6 divided by 2, which is 3, so 3 squared. On the outside, I would subtract 2 times 3 squared. And we're subtracting it on the outside because I'm not just allowed to add 9 anywhere I want to. I need to keep this equal to the original expression, so I have to subtract the value on the outside. Okay, so let me show you what that looks like. So this is what we got when we did that work. Now I know it looks more complicated than the previous term, but we are almost done. What we're going to do is we're going to factor this part next. This is a perfect square trinomial now. That's the point of completing the square. And what we'll do is we'll keep one thing from each term. We keep the x from here, keep the minus sign from here, and the 3 from here. And then that whole thing is going to be squared. And then we're just going to simplify this part and do 23 minus 18. And that's going to be our last step in changing this to vertex form. So our new function is 2 times x minus 3 squared plus 5. And this is the same parabola that you would have gotten with this other function. It's just written in a different format. Okay, let's look at what we can do with this now. So there are various things that we can do with it. Let's see what those are. Okay, the first thing that I can do with it is I can sketch the graph. Now I have this in vertex form. I can go ahead and find the vertex, which is 3, 5. Remember, we changed the sign on this x. Okay, so I can put that on my graph at 3, 5, and I'll do that in a minute. Now, I can also use the y-intercept. This one actually does not fit on my graph. I have this small bit of graph paper. It would be up at 23, so I'm not going to put that on there. But I can get other values, other ordered pairs, simply by just picking x values and putting them in and getting y values. And I did that with the value of 2, x equals 2. And I just took 2 and I plugged it in, and I did 2 minus 3 is negative 1, and I squared it to get 1, and then I did 2 times 1 plus 5 is 7. So that gets me the point 2, 7. And you can do that with as many x values as you want. I definitely recommend sticking close to your vertex. So let me show you what this parabola will look like. Okay, so this is the graph of my parabola. I always recommend getting 5 points. It really gives a better shape to your parabola. In this case, the 5th point, the next 2 points would be 113 and 513. But again, they did not fit on this little bit of graph paper I gave myself. If you're graphing on graph paper, obviously, you could use as much as you wanted and then make it fit. Okay, let's look at the next application of quadratics. Next, we're going to find the x and y intercepts. In this particular parabola, the y-intercept is 23, but it doesn't have any x-intercepts because it doesn't touch the x-axis. So we would just note that. If it did touch the x-axis, you would give whatever x values those were. Next, they want us to find the maximum or minimum value. This is always found using the vertex. It is the y value of the vertex, so in this case it would be 5. And again, you could note, like we have been in the past, what x value that happened on. And because this is a parabola, there is only one maximum or minimum value. You don't have to note that x value because we know there's only one. So it's okay not to. Usually we do just for clarity's sake. So in this case, I would have a minimum, because it's an upward parabola, a minimum of 5. Okay, finally, they're asking me to find the domain and range. And the domain for any parabola is going to be all real numbers, unless you're doing an application question in which negative numbers don't make sense. And the range is going to be an inequality, because remember, it describes the y values that you're allowed to have. In this particular case, all the y values are greater than or equal to 5 because it's going upward from 5. So let me show you what that would look like. So the domain can just be listed with the real number symbol, and then the range is y is greater than or equal to 5. Let's look at another example where they're asking us to find the maximum or minimum of a parabola. Okay, in this example, they're giving us these 2 different equations, and they want the maximum or minimum of each one. Now, it's important to note whether it's an upward parabola or a downward parabola. This one's upward, so I'm going to have a minimum. And now, what I would recommend doing, instead of going through the completing the square steps, I would recommend using that formula, negative b over 2a. So I'm going to show you the work for that, for letter A. Then I would encourage you to try B before allowing me to play that answer. In A, I did negative B over 2 times A, and I got negative 2. That's the x value. But now I have to take that and plug it into my function to get the y value. The y value is negative 4. So the parabola is upward, so negative 4 is a minimum value. Okay, and it happens when x is negative 2. So I would encourage you to pause the video, try B on your own, and then hit play to see the answer. Okay, here's the answer. X equals negative 4 over 2 times negative 2. That comes out to be 1. And then you take the 1 and plug it in, and you get negative 2 times 1 plus 4 times 1 minus 5, which is negative 3. And I apologize for having F instead of G there. I should have copied the value. The parabola is downward, so the value is a minimum of negative 3. Okay, we have one more example to look at. Okay, this example is an application of parabolas and quadratic functions. I definitely recommend spending some time with this. This is something that people tend to struggle with on their tests and quizzes. The example says, most cars get their best gas mileage when traveling at a relatively modest speed. The gas mileage m for a certain new car is modeled by the function m of s, and they give it here. And they do clarify that s has to be between 15 and 70. They say s is the speed in miles per hour and m is measured in miles per gallon. What's the car's best gas mileage and at what speed is it attained? So notice they're asking for a maximum, the best mileage. So they want the maximum of this function. So this is just like that previous example that we did. We're going to use negative b over 2a, find out that value, and then take it and plug it in. So x equals negative 3 over 2 times 1 over 28, negative. And if you plug this into a calculator, you get 42. You can also simplify this. 2 times this fraction is negative 1 over 14, and 3 divided by that fraction, you would actually end up doing 3 times 14 because of fraction division rules. But you get 42. So that is the S value, the speed at which it happens. So it happens at 42 miles per hour. To find out that mileage, you would just take that and plug it into the function. Again, I'm very sorry that I didn't make my variables match up. You take 42 and you plug it in, and again, I recommend a calculator. You get 32 there. So the best gas mileage is 32 miles per gallon, and it happens when the car is going at a steady speed of 42 miles per hour. Okay, so that's it for this lesson. Please make sure to ask me if you have any questions.